I wish you a very happy birthday to the students who are celebrating their birthday today. Before watching the class, my sincere request is grab a notebook and a pen to take notes from our videos. Believe me, it helps a lot in the process of learning.
Today we are going to discuss about balanced and unbalanced forces. When do we say something is balanced? Children, what do you observe here? Yes, it's a common balance, right? Is this balance balanced or not? Tell me, is this balanced or not? Yes, very good. It is balanced. Clear? How can you say that it is balanced? So you see this is aligned along a straight line, right? Right. When this will happen, you know very well when this will happen. This will happen if both the sides we put equal amount of mass. Is it correct, children? Both the sides, if you put equal amount of mass. Clear? So now you understood. Means if we keep both the sides equal amount of mass, then we say that it is balanced. Now let's see another one. What do you say about this one? Is it balanced or unbalanced? Yes, very good. It is unbalanced. Or you can say it is not balanced, right? Because this side we have more mass than other side. Here both the sides you do not have equal mass. The mass here is unequal mass. Clear, children? If you understood, then balanced and unbalanced forces are very easy to understand. Now, I think you got some idea about that. Yes, exactly. So, for example, there is an object, my dear. This is an object, assume. So, on this object, two forces are acting. Okay? This side one force is acting, this side another force is acting. Let us say this is F1 and F2. Okay? If F1 is equal to 10 Newton, and F2 is equal to 5 Newton. Clear? Right. What do you say about these forces? Are these two forces are balanced or not? Very good. They are unbalanced forces. Clear? Okay. These two forces are unbalanced because both the side unequal amount of force is acting. One is 10 Newton, other one is 5 Newton. Now let's see an other example. So now this is an object. On this object, this side 12 Newton force is acting. Let me write this as F1, and other side F2, which is equal to 12 Newton. What do you say about this, my dear? Yes, very good. These are balanced forces. Hope you understood. If two equal forces acts on an object in opposite direction and they act along the same line, remember that they act along the same line, along the horizontal line or along the vertical line. They can be along horizontal or vertical line, but they must act along the same line. Okay, so when two equal forces act in opposite direction, then the forces are said to be balanced. If two unequal forces acts on the body in opposite direction, then they are said to be unbalanced forces. Very simple, right? Hope you understood, my dear. Now let's find out whether the forces are balanced or not in the given situation. So in the first situation, you can observe 15 Newton force is acting towards left and 15 Newton force is acting towards right in this situation. Here, two equal forces acting along the same line in opposite direction. Therefore, these forces are said to be what, my dear? Balanced. Very good. Coming to second situation. Here, how many forces do you see? Only one force, which is 2 Newton acting vertically downwards. Is there any other force to balance this? No. Therefore, what do you say about this? This is a unbalanced force. Clear, children? There is no other force to balance it. And see third situation. Here also two forces acting. One is acting towards left 300 Newton, other one is acting towards right 350 Newton. Are these two balanced each other? No. Okay, one is 300, other one is 350. So 350 is greater than 300. So we can say these are unbalanced forces. Yes, my dear, they are unbalanced forces. Clear? Let's see situation 4. Here, how many forces are acting, my dear? Tell me. Very good. Two forces are acting here. Okay. One is acting vertically up and other one is acting vertically down. Two forces are acting along the same line. Very good. And are these two equal or not? Yes, these two are equal in magnitude. Their values are same. So, whether these are balanced forces or not balanced forces, they are balanced. Super. Now coming to situation 5. See, here also two forces acting. They are acting horizontally along the same line. One is acting towards right, other one is acting towards left. Okay, are these two equal? This is 210 and this is 500. They are not equal, so it is unbalanced. Clear? And see the last situation. Here also two forces acting. They are acting along the same line and they are acting in opposite directions and their magnitudes are equal. So what do you say about this? These two forces are balanced. Very good. Hope you understood when we say forces are balanced and when we say forces are unbalanced. Let's see the physics behind the tug of war. Have you played this tug of war game, children? You might have played, or at least you might have seen when two teams are playing this tug of war. So, in this war, a lot of physics is involved. Clear? Let us see how balanced and unbalanced forces makes the team to win. Clear? See here. Team A and Team B. Team A and Team B. Both are applying same force in opposite directions. Clear? In opposite directions. Okay. So now let us say this is some 100 Newton force and this is also 100 Newton force because they mentioned here it is same force. Now tell me which team is going to win? Team A or Team B? Very good. Neither Team A nor Team B. Okay. Here the forces are balanced. Therefore, this object will not move either towards B or nor towards A. So we can say that no team is going to win in this situation. Clear? Now see here. Here unbalanced forces are acting. So team B is applying greater force and team A is applying less force than team A. Here let us say this is some 500 Newton and team B is applying 200 Newton. Now tell me which team is going to win, my dear? Exactly, team B is going to win since greater force is acting towards the team B. So are these forces balanced? No. Here this is 200 Newton and this is 500 Newton. So now the forces are not balanced. Therefore, this object would move towards the greater force. Therefore, these people are going to win the tug of war. This is the logic behind tug of war, my dear. So which team is going to apply more force, that team is going to win the tug of war game. Hope you understood. In many situations, more than one forces act on the object at the same time. All these forces collectively produce the same effect in the body as if a single force is acting on the body. Such a single force is called net force. Simply, here many forces are acting on the body. Okay, see, two forces are acting in the direction of east and two forces are acting in the direction of west. These all forces can be represented by a single force, either this direction or this direction, depending on its magnitude. So this we will be calling as the net force, either this or this we can call as the net force. When two or more forces act on the body in the same direction, then the net force is the sum of the two forces. See, for example, this is a body. On this body, two forces are acting. Let us say this is F1, which is equal to 20 Newton in the direction of east, and let us say this is F2, which is equal to 5 Newton in the direction of east. Both are acting in the same direction and they are acting along the same line. Remember this, they are acting along the same line and they are in the same direction. Then the resultant force or net force is the sum of the two forces, means F1 plus F2, simple, which is equal to 20 plus 5, which is equal to 25 Newton. What is the direction, my dear? Here two forces are acting in the direction of east, so the resultant force also will be in the direction of east. Clear, children? Now let us see one more example. In this example, on an object, see, this is a force of 4 Newton which is acting in the direction of north, and this is a force of 5 Newton which is also acting in the direction of north, and this is 2 Newton acting in the direction of north. See, all are in the same line. Clear? So now what is the net force? These all forces can be replaced by a single force, that is called the net force. Now see, how much is this? All the forces are acting in the same direction, therefore let's add these all. 4 plus 5 plus 2, which is equal to 11 Newton in the direction of north, children. Clear? So we can replace these all forces on this body as this 11 Newton simply. Okay, so now this 11 Newton is known as resultant force or net force or total force. Hope you understood, my dear. Very good. If you understood, let me know through your likes or comments. Now let us see another one. When two forces acts in opposite direction, then the net force is the difference of the two forces. Suppose this is an object. On this object, now two forces are acting in the same line. They are acting in the same line, but in opposite direction. Let me take this as a F1 force, which is 20 Newton, F2 force, which is 50 Newton. F1 is acting in the direction of east, F2 is acting in the direction of west. Both are acting along the same line. They are acting along the same line, but they are in opposite direction. Then these two forces can be replaced by a single force, which is net force is equal to the difference between the two forces. So 20 Newton minus 50 Newton, which is equal to 5 Newton. 5 Newton in which direction? Observe here, which is the greater force? 20 Newton is the greater force, 15 Newton is the smaller force. Now the net force will be in the direction of greater force, my dear. So 5 Newton east. While you are subtracting also, remember that first you write the larger force and next you write the smaller force. Means from the larger force you are subtracting the smaller force. So the net force is the east. So now you can replace those two forces simply with a single force, which is 5 Newton east. This is the net force. Very simple. Clear, children? So when two forces are acting in the same direction, we add them simply. If the two forces act on the body in the opposite direction, we subtract them. Simple. Now let's see a few more examples. Now this is your body. On this body, several forces are acting. See here, this is 40 Newton in the direction of east, and this is 30 Newton in the direction of west. Here 20 Newton in the direction of west, and 25 Newton in the direction of east. Here how many forces are acting, my dear? Very good. 4 forces are acting on this body. Now let's find what is the net force acting on this body. So we can replace all these forces with a single force on this body. Now let's find what is its magnitude and direction also. So first find out which are acting in the same direction. First let me count from the east. So 40 Newton is acting in this direction and 25 Newton is acting in the same direction of 40. So let me add these two first. So 40 plus 25. 40 plus 25, which is equal to how much, my dear? 65, which is acting in the direction of east. Clear? 65 Newton. Next, observe these two, 30 Newton and 20 Newton. These two are acting in the direction of west. So add these two. Again, these two are acting in the same direction. So add them. How much is that? 30 plus 20, which is equal to 50 Newton. This is acting in the direction of west. Clear? So therefore, now what is the final net force? 65, which is the larger one here. 65 and 50. 65 is the larger one, minus 50, which is equal to how much, my dear? 15 Newton. What is the direction of this net force? In the direction of 65, that is east. So these all 4 forces can be replaced by a single force of 15 Newton. Clear, children? Hope you understood. Very simple. You observe which are acting in the same direction, add them, and which are acting in the opposite direction, subtract from those. Simple. You try these questions. See, in both the situations, forces are acting along the same line. Here, along the vertical line, the forces are acting. Here, along the horizontal line, the forces are acting. So, if forces act on the object in the different directions, I mean, one force is acting in this way like 15 Newton, another force is acting in this line like 10 Newton. Okay, you can't use this method to find out the net force. Clear, children? When the forces act along the same line, simply you use this method to find out the net force. In this case, we can't use that method. After all, I would like to ask a question. Try to answer this. This is an object. On this object, 2 forces acting. One is 25 Newton and other also 25 Newton. Now tell me, is it balanced forces or not? That is my question. And second one also. This is a object. On this object, 2 forces acting. This is 10 Newton and this is 10 Newton. Let me know whether these are balanced forces or not. Let me give a name to this one. This is situation A and say this is situation B. Tell me, in situation A it is balanced or not, and in situation B whether the forces are balanced or not. Let me know in the comment sections. So I'll give a hint also. So whenever net force acting on the object is 0, then we say that those forces are balanced. Very simple. Clear? When the net force acting on the object is not equal to 0, it is something 2 Newton, 3 Newton, 5 Newton, 10 Newton, whatever it may be, then we say that the forces are unbalanced. Very simple, my dear.